This is a tutorial on conducting a one-sample t-test in Excel 2016. So the first thing we want to do is we want to open a new spreadsheet and copy our data of interest, in this case phone time use, and paste that into the new spreadsheet. Now we have a separate spreadsheet with our data of interest. Now before we start the t-test, we're actually not going to be using the data analysis tool pack for a one sample test because they do not have a function that performs that operation. Instead, we're going to be using Excel as sort of a calculator to do the t-test manually. So before we get started, we're going to need a few things. We first want to calculate the mean for phone time, the standard deviation, the sample size, as well as the standard error and the degrees of freedom. So for the mean, we can use the average function to get mean phone time use. For standard deviation, we can use the standard deviation function in Excel to get that. Sample size, we can use the count function to get our n. And our standard error is going to be equal to our standard deviation divided by the square root of n, or our sample size. Our degrees of freedom will be equal to our sample size minus 1. Okay. So we're going to be conducting 3 separate one sample t-tests. 2 of them are going to be one-sided, and then the final test we'll conduct will be a 2-sided one sample t-test. So first off, we're going to start off with a right-sided one sample t-test, or a greater than hypothesis. So let's say, based on previous evidence, we believe that the true mean phone time use is 14.5. Maybe this is a measurement that has been collected in previous years. And we want to test whether our sample mean for phone time use is significantly larger than this null mean. So to do that, we need to first calculate a t-statistic. And the way we do that, to do this, we take our sample mean and subtract from that our null. This is in turn divided by the standard error, and this gives us our t-statistic. We can get a p-value for this t-statistic using an inbuilt function in Excel. That function is t.dist.rt, so it's a right-tailed. We're looking at a greater than hypothesis, so it's right-tailed. We enter in our t-statistic, comma, and our degrees of freedom. Hit return. We have a p-value for this hypothesis test. We can also calculate a t-critical value. And to do this, again, we're using a built-in function in Excel. This time we're using something called t.inv. Now, since this is right-sided, we want to have our probability be equal to 0.95. And again, our degrees of freedom is equal to 74. Hit return. So for this one-sided, right-sided, or greater than hypothesis test, we have a t-statistic, a p-value, and a t-critical. Now let's say another data set that was previously collected indicated that the average phone use per week for college students was 20.5 hours. And we wanted to assess whether our sample mean was significantly less than that null. So now we're still doing a one-sided test, but we're going in the other direction. So this is a left-sided or a lesser than test. So again, in this case, our null is 20.5 hours per week. So as before, we're going to want to calculate a t-stat, p-value, and a t-critical. So the t-stat, again, is going to be equal to our mean minus our null divided by our standard error. Our p-value will be equal to t.dist. Now this is left-tailed, not right-tailed, so we don't want to use the .rt. We just want to use t.dist. We want to enter in our t-statistic, our degrees of freedom, and we want cumulative to be equal to true. We hit return, get our p-value, and then finally, to calculate our t-critical, we want to use, again, the t.inv function, only this time our probability is set equal to 0.5, and again our degrees of freedom are 74. So for this one-sided lesser than test, we again have a t-statistic, a p-value, and a t-critical. And finally, let's say we had no a priori reason to believe that our sample mean was significantly greater or less than this null. Instead, we just wanted to know whether it differed, regardless of the direction. In this case, we would do something called a two-sided one-sample t-test. So again, let's say our null is still 20.5 hours of phone use per week. So for this test, we're again going to calculate a t-statistic, p-value, and a t-critical. So our t-statistic is going to be equal to, as before, our mean subtracted by our null and divided by our standard error. Now to calculate our p-value, we're going to be using the t.dist.2t function. So we're doing a two-tailed test, so we want that .2t function. Now this function only takes input of positive t-statistics. So for whatever t-statistic you have, you want to input the absolute value, the positive value. So even though our t-statistic is negative 1.978, we're going to actually input the positive value. So we're going to input 1.9787. We want to do the positive because it will not accept a negative t-statistic. It only looks in the single direction, the positive direction. And again, for degrees of freedom, it's as before, it's going to be 74. Click return. We get a p-value for our two-sided test. Now for our t-critical, we want to use the t.inv 2t function. And for our probability, we want to use 0.05. And our degrees of freedom, again, is 74. Hit return. So for our two-sided one-sample t-test, we again have a t-statistic, a p-value, and a t-critical.